And we are back. All right, so we needed to do a test run to see if our changes to the code have been applied correctly, or if we ended up derping up a lot of the JSON handling. Let's just do a run and see what happens. All right. For this to properly work in terms of testing stuff, we need to keep an eye on the output window down here, and we should probably also fire up the server so we can at least see what's going on. Let's see, do we actually have to? Well, this part of the code basically only attempts to send the message to the game server if it's actually running. So in reality, we don't really need to fire up the server just to test whether these changes have been applied correctly. So let's just do a run here and see what kind of output we get. Copy this, and then we'll go through and see what kind of stuff we ended up getting. Like so, and then I'll put it in here. Alright, let's see. Test message, this is the stuff that came in, and line these up like so. Okay, so the conversion process from converting from ampersand to the section sign was correct. The next part is the new JSON build up. So we kind of need to go through that and check that it was done correctly as it's supposed to be done. And so far it actually looks correct. Yellow there, and the red stuff there, and the minutes yellow. There we go. So this part is correct. What we don't have in here is any of the actual text formatting control characters. So to test that, we will go through and do, let's see, we will make server right here. We will turn that into bold and underlined just to see if that actually works the way it's supposed to. And then we'll see eventually how the game chat treats these differences. So to get bold, we need to specify the L, and to get underlined, we need to specify the N. So we'll put and L and N to make this part bold and underlined. Do another run and see what kind of output we get. Grab this, copy, and see if we can stuff it down here somewhere. There we go. These are basically identical. Here we can see that they got converted correctly. So next part is checking that the JSON got converted correctly, or got constructed correctly, sorry. So far it actually looks as if we got some extra properties on here that we didn't have before. So there's definitely something new. Whoops. You were not supposed to start up. Nope. There we go. We need this one. Okay, so major difference. This line of JSON is definitely different from this line of JSON. Let's check that these are actually correct. Bold is in quotation marks as is expected, followed by a non-quotation marked true. Underlined is in quotation marks as expected, followed by a non-quotation mark true. So that part is correct. All right. Um, Now, as you can see, these particular properties are not reset anywhere else. So that basically means that whatever text is in here past where these are initially set should stay bold and underlined for the remainder of this particular chat message. So we will see if we can um, replicate these down to the actual test on the server itself, and then see how the server and game client end up rendering these. So we'll check that by firing up the server and then connecting to the server with the game client, and then do a test of the button to see how it's actually rendered in the game. There we go. And we'll start up the vanilla server. I've already, as you've seen, the game client is already running. And there we go. Keep this one up, and we'll refresh this quick, and then we'll join in and see what happens. So let's try the test button and see exactly what happens. Boom. Nice one. Okay, so what exactly happened here? Well, it would appear that the that the game itself automatically toggles these off between each chat element. So just by us basically dividing the contents of the message being sent into individual chat components basically tells um, um, tells the chat handling that each one should start as a basically reset element, and then whatever properties we change on top of that will then affect this particular chat element only. Okay, so toggle option not really available since we are sending this exact setup. That's basically what we're sending to the server itself, which means that it internally defaults these back to a reset state, as is evident by the fact that only server became bold and underlined. Okay, so that's something we need to keep in mind when constructing these basically custom colored messages and such. All right, let's shut this down. There we go. User got kicked. Server shut down, and we're good to go. Okay, well, we know that it got fixed, so sorry, we know that it still works. So the next part will, of course, be to basically replicate how the server decides to handle what's going on in chat as part of the individual chat elements. when we build the text rendering stuff for showing these custom colored and custom formatted chat texts as part of our UI stuff. So that is definitely something that we need to note in here. Note the game basically treats each chat element as having been reset before it's drawn in the chat box. So when we build our text rendering, we have to treat each individual chat element as if it were reset. There we go. So that's something that we definitely need to keep track of when we build the actual rendering code. All right, so now that we put this in, we may want to do one more test, which would be something along the lines of trying to do something in italic just to see exactly how the game client actually renders italic characters. So let's give that a try. Italic would be the O, so we'll put in O there, and then do another run. Start this up. And there we go. And then we'll join this again and see what happens when we hit the test button. Okay, so as we can see, the instant we hit the 10 over here, it pretty much instantly resets the chat element back to its default state, then applies the red and continue handling them from there on. Now, for this particular setup, the situation is that I've pre-configured the client to basically use double scale of the UI, so it's more visible, which basically allows the actual chat renderer to offset by half a pixel compared to the original one. So that's something that we maybe want to do something about. Let's go into the options here and set the GUI scale to small, and then check the chat again. Now here things look quite different. So if I do this, we get a screenshot, and then I'll see if I can pull up that particular, no, that would be the client instances, which should be this one, screenshots, and let's have a look at this quick. There we go. So here is a better indication of how we should handle italic text. And it looks kind of very, very weird. So basically, we need to compare this with how the glyphs are rendered normally, and then do this kind of offset in a similar fashion, so we can properly simulate that it's going off in italic. For the sake of comparison, we'll set this back to normal. and then um, grab another screenshot here, since this is now in double mode. Um, we'll have, let's see, shut this one down. For some reason it's unable to recognize new files. Okay, so as we can see here, these basically accept that 1 pixel within the glyph is rendered as a 2 by 2 pixel dot on the actual surface, which allows for basically half a pixel offset. So this would tell us how to render the italic mode when we need to render the text in basically in double size, which is basically what I had envisioned for our UI, since this text is pretty darn small. It is a little easier reading this, there's no doubt in that. So we might want to be able to handle both of them. We could even grab the larger one and then do a screenshot of that as well, just to be able to see the actual differences. Video settings, so that would be the GUI scale large. For this, I do believe that yes, I need to do something along these lines. And there we go. Now we have it in basically triple mode, so we can upscale the italic handling for this as well, should we want to. Honestly, I don't see any need for it. So for now, I think we will just do the double font size mode, and that's it. Set this back. There we go. And then we'll keep these as reference. So let's disconnect from here, and then go grab our server here and stop it. There we go. And then see what we can get done. All right. At least now we do have a reference that lets us figure out exactly how we will end up doing these actual text renderings. Okay, so the thing that we kind of need to do as part of the font rendering or text rendering using the Minecraft font is that we need to be able to basically pass a pre-formatted text to the Minecraft font object, and then internally let it do all of the conversion stuff, do the setup of the chat elements, and so on and so forth. In terms of us basically following what the server and game client do, we may want to update this to correctly reset the elements individually, so that it follows what the game client and game server do in terms of throwing the text in the chat. Whether we should do that or not, good question. Nah, for now we'll leave it as is. Okay. One thing that we do need is to be able to basically render render the text, maybe return a bitmap that we can then put somewhere. possibly be able to say pass a graphics object along with the text that we want it to render with say a position and then basically let the Minecraft font figure out what to do about it. So we can add in a couple of different methods to determine exactly how we want to draw this particular text. In any case, we do know that we need to be able to um, do the text conversion by means of the chat converter and then handle it from there. So let's get rid of this one, get rid of this one quick. Let's get rid of this one. We may have to add a bunch more stuff in here. Public methods, that's it. Okay. So, one of my chinchillas has just woken up and wants out. And unfortunately, that's a bit too early, my dear. It's a little bit too early, my dear. You'll have to wait. All right. Back to the problem at hand. Let's see. We'll see about adding in some yes, we'll do a I don't know, drawstring that kind of fits with the normal stuff. Drawstring, and then we'll do a couple of different overloads depending on what kind of handling we want for it. So we'll do a public for this initial one. We want it to return a bitmap that contains the text and some kind of no, actually we just need the text, and that should probably be chat text, just to stay in line with the rest of it. Of course, we could add add in a maximum available width in pixels, so we can potentially add in things like word wrapping or some kind of alternative way of ensuring that this particular text can only fit within this particular width. When it comes to drawing the or rendering the sample MOTD stuff, there is an allowance for specifying \n as a new line as part of the MOTD text, which would then cause this particular setup to occur. And that's something that we definitely need to put into our rendering routines for our setup. So we need to keep that in mind. For now, we'll return null here. We also want to have an instance where we can specify a graphics object. So we'll put drawstring, chat text that we want to put in there. We want to be able to specify a graphics object and some kind of position. So we'll put a point, and this will then let us have this render the text directly on onto some kind of graphics surface, and we'll do it that way. All right, so how are we going to do the actual rendering of this stuff? Well, we know that the italic setup, as we found out, is a little bit different. We know that in a single pixel mode or normal scale, it kind of does offset these things a little bit, like so. Potentially this tells us that there might also be a spacing difference in terms of how many pixels it sets up for a white space between a italic and non-italic text. This should be able to tell us 1, 2, 3, 4 pixels plus the shading at the initial letter spacing. So basically this tells us that it kind of tries to stick within the already assigned spacing and then offset things a little bit there. So that at least is a little bit of a hint in terms of how it should be rendered. So the next part of it would be to figure out what kind of space we need available in terms of the amount of pixels required to basically render this particular text that is being passed. In a situation like building up a rainbow and bold and stuff like this one is, we would definitely need to investigate each individual chat element to figure out exactly how many pixels each individual chat element takes up, and then size that up. So that's something that we need to do to begin with. Before we start doing that, we need to grab the chat text that is passed and convert that into the individual chat elements, and from there we can then go through and determine whether we need to add, say, 1 pixel to the entire setup because each individual element has a bold to it, or whether we need to add to the height to be able to do the underline, whether we need to do a strike through, and so on and so forth. So those are elements that we definitely need to be aware of. We'll go back to this one quick, just to recap this quickly. As we can see here, the underline is actually placed on the 9th pixel in height, which means it's actually placed 1 pixel below the total height of a glyph. And for the chat aspect, it adds yet another pixel where it renders the shading. So we definitely need to specify on as part of the a set of control properties, we definitely need to be able to tell our Minecraft font renderer whether we need to add shading to it, which would then bump up the height of each line to effectively be capable of rendering 10 pixels in total, since each glyph is basically 8 pixels high. So it's a little cheating, I guess, but we'll get there. All right, so let's see. Drawstring would basically be the main rendering handler, I guess. So actually, let's see. We probably wanna, yeah. Let's start by adding in some helper methods, because we need to figure out how big this thing is going to be in terms of how many pixels width and how many pixels height. We probably also need to add in some control properties for miscellaneous different offsets and whatnot. So let's start by adding those. This would be the properties, and for those we know that we need one to basically control whether we want shadows on. So let's do a property for shadows, get set, and we'll do this as false to begin with. We know we need some kind of glyph spacing, which we should set default to 1. So we'll do we'll call this I don't know, letter spacing. I have no clue what it's actually called in real font construction. We'll call it letter spacing. And whoops, wrong kind of brackets. Get set, and then we'll default that to 1. This we may need to change at some point to put some min-max handling in there, just to kind of try to avoid some kind of out-of-bounds calculations. Whether the individual parts of the text that's being rendered is in bold, underlined, italic, strike-through, all of that stuff is handled through the actual control codes that are in the chat text. So that part we don't really want to waste too much time on. But we also need to figure out whether there is an occurrence of a new line in there, because the text may contain a new line reference. So if it does, we need to split it into 2, which then increases the height of the resulting graphical element that we're going to have this one produce. To allow for a little bit more customization there, we can add in, say, a default line height of 8 pixels for the purpose of being able to render underlined. We should probably force this to be 9 pixels, thereby ensuring that we can at least draw the actual line down here, even though, as shown here, it actually falls outside the area where the chat is being rendered. So here's a perfect example of things being offset beyond the intended bounds. Something that Mojang actually, in my opinion, should have fixed a long time ago, but they haven't. It's just part of the stuff. In any case, this is something that we need to be able to handle, especially when we want to custom render all this stuff. And the basic premise is that we throw the pre-formatted string at this Minecraft font thing, and it then returns either a bitmap that contains all of the rendered text, or draws that particular bitmap onto some kind of graphical surface, depending on which of the 2 drawString methods we use to get this rendered. So we'll take it from there. Now, excuse me, if we have a quick look at the spacing between these two lines of chat text, we can see that right here there is a spacing of 2 pixels between the 1 and the 2 down here. Now, as we can see down here, letters like P and G and Q and such, they actually reach 1 pixel further down. And if we count these, 1, 2, 3, 4, 5, 6, 7, most of these glyphs are actually only 7 pixels in height. But we know that the glyphs are 8 pixels, so that's sufficient to include these. Which means that the red shading right here would actually be the bottom of the glyph above. So basically that tells us that it's putting a line height of 9 pixels in here to make room for some kind of line separation, which is why I did the line height, default line height of 9 pixels. That then allows us to basically squeeze in an underline, just like we've done here, or the game client did here. So, so this is primarily for us, for our purposes, to be able to calculate the sizes and distances needed. Okay. There we go. So these properties should be set before drawstring is called. Otherwise they of course won't bubble out, since drawstring is the one that will eventually produce the actual rendered copy of the text itself. Alright, so let's see if we can get some kind of calculation done to try and calculate exactly how much space is needed to produce the rendered result that we want. And how are we going to do that? Well, we definitely need to grab the chat text and split it up to figure out what kind of customization has been done. So let's actually start down here. This will be the main method for getting all the rendering done. So first of all, we know that we are going to need an array of chat elements. So we'll grab the chat elements from the chat converter, 2 elements passing the chat text. There we go. Alright, so this one now tells us the total number of elements within the passed string. However, it does not at the moment include the option for specifying some chat text. This is on a new line. This particular instance is allowed in the server properties, not in the in-game chat. But for the server properties, this would be a case where we need to look for it and we need to handle it. Which means if we are grabbing the pre-formatted MOTD copy of this setup and passing it to drawstring here, this one needs to be able to render that correctly. So we need to kind of look for this and then perhaps split chat text into multiple individual instances, and if that's the case, then we need to handle those individually as individual lines. Alternatively, We could have drawstring force a removal of it, and then do an overload which accepts 2 lines or multiple lines. In any case, it's something that we need to worry about it. Okay. Um, let's see. We are getting the individual elements, and then we need to calculate exactly how much space we need to render all this stuff. So, in the case of an element being set bold, we will need to basically add 1 extra pixel. Let me see, where is it? Right here. This is the better example of it. Actually, we kind of need to see how the renderer does this, because it sure looks like it kind of stays within the same size, which is interesting. No, it actually does add 1 more pixel to it. We can see that here. So, in rendering a bold text, we need to add 1 pixel to the glyph width for every character within the bold chat element that's being added to correctly render the bold text. We may need to add 1 pixel extra for the total width of italic just to make it fit in there. We'll see when we do that part. For now, we'll keep in mind that we definitely need to add 1 pixel to each letter's width when rendering bold text. So that's part of the calculation that we need to do. For text that is strike through or underlined, stuff like that, they don't exactly change the width of the text itself, so there it doesn't really matter. We just need to count up how many characters there are and basically fetch each individual glyph and figure out how wide it is. So let's see if we can get some of that stuff done. All right. There's actually one tiny problem that we haven't considered at the moment yet. And that tiny problem is that at the moment the chat text that we get in is basically handled as if it was UTF-16, as we can see here, represents text as a sequence of UTF-16 code units. And since we are using an ASCII glyph set, we kind of need to convert these into ASCII to get them listed correctly, I guess, especially for the international characters, for example. Otherwise, we're not going to end up getting the correct positions within the glyph atlas. So we may need to do some manual conversion there, because I know from experience that using the text encoding to convert it into ASCII basically by definition always converts this into this. So the U umlaut, which is available in the default ASCII setup, code page 465 or whatever it's called, 437, for some reason it gets encoded into a question mark. So that's one instance where we kind of need to do some manual encoding of that to get it converted correctly. Because if we take a look at the glyph list here, in here somewhere, both the upper and lowercase version of the U umlaut, that's the uppercase one, and the lowercase one is in here too, right there. I know these by heart because they are part of my family name. And I also know that whenever we use the built-in text encoding to convert them to ASCII, they do end up as question marks. And there are a couple of other of these special characters that the text encoder for some reason decides, oh, that needs to be a question mark because I can't figure it out. And to some extent, you could say that the text encoder is correct, given that the code page of the ASCII encoding matters in terms of selecting the correct value for this particular character. Now, one would assume that Microsoft, having worked out these original code pages with IBM, could, at least to some extent, assume that the default code page that they initially did as part of DOS would be the code page that they ASCII convert to, or grant us the option to basically specify which specific ASCII code page we want to convert into. Neither option are available, so we kind of need to work around Microsoft's typical ineptities when it comes to doing things like these, and then figure out how we want to set this up to get it working properly. All right. Yes, let's continue on and see what kind of mess we can get ourselves into. For the moment, let's just assume that all of this stuff will be plain English, so we don't have to worry too much about it. The instant we go to Danish or German, or Swedish, Norwegian, Finnish for that matter, French, we'll run into trouble, but we'll just for the moment assume that this is just English and then take it from there. I'm fully aware that to do this for full support, basically we would need to be able to figure out how all of the individual glyphs that are available as part of the game itself, that we can build up some kind of translation table that fits with how the game handles Unicode setups, and then do all of it in Unicode, so we can work it out the same way. At the moment, that's not an option, so we'll have to start somewhere. Okay, so we need a method that can calculate the width required for this list of chat elements, so we can work out exactly how wide we need to make the resulting bitmap. So we'll create a helper method that can do that for us. Calculate required width, and then for this we will pass the list of chat elements. It'll loop through them, figure out exactly the width of each individual character, and then through that return a result in exact pixels, so we can can create the graphics surface on which to render the glyphs individually. Of course, this calculation kind of depends on the letter spacing, as well as the individual chat element setups. For shadows, that's purely a matter of adding the shadow stuff when we actually start doing the rendering of the individual glyphs. So that's part of the rendering routine. This one just needs to tell us exactly how many pixels we need to fit the text in there. So we'll do a int for that, and then here we'll just use the array of elements that we already have. Again, I'm passing a reference to the array that we've got here so that we don't have to spend extra memory on the heap just to copy the contents of it over to this method. So we'll just put a reference up there. Okay, there needs to be some kind of result. So we'll start by declaring that and then return it down here. And from here we need to loop through the elements and figure out exactly what kind of size we need to set aside for these individual glyphs. This will, to some extent, produce a problem, given the fact that the actual text represented within each individual chat element for the text property is UTF-16 encoded, and the glyphs are ASCII encoded, so there will be some differences that we need to work out. In any case, for now, let's just see if we can get some of it partially working at least. We need to loop through each individual element so that we can figure out what kind of extras we need to add in terms of extra spacing for some of these custom setups. One of them would be for the bold, which we know for a fact needs to be 1 pixel extra for each individual letter. So we definitely need to account for that. So for here we will actually, let's put it up here. Bold extra, set that to 0, and then we'll check if this element has its bold flag set to true. Then we'll set bold extra to 1 pixel extra, and otherwise we'll set it to we'll do bold extra equals 0 here. So only if the bold element is set, it'll add 1 extra pixel, 1 extra pixel per rendered character or glyph. Okay, next up we need to loop through the individual symbol characters within the text property, and then calculate up the width of each, and this is where things can get a little bit hairy. So at some point we may want to see about adding in a proper UTF-16 to ASCII encoding, so we can get these set up correctly, and then take it from there. Alright, so let's loop through the t less than elements e.text.length. t plus. There we go. And this will then allow us to reference each individual character within the text property of the current chat element. These are things that we need to know so we can properly reference each individual glyph and fetch the actual width of this plus bold extra plus the letter spacing so we can correctly determine the actual width of this. So for this we'll do char index equals, and I know that this could potentially fail, like so. Quick and dirty way of doing the ASCII conversion. And here we'll then go through the, let's see, char index. It's called glyphs. So for the result, we need to add the width of this character, which would be that one, plus bold extra, if there is such a setting, plus the letter spacing. There we go. That's what we need to add for each individual character for this particular setup. And when we're done doing this, we basically potentially could remove the last set of letter spacing. However, in doing that, we will effectively remove the option that would allow us to have this trailing shadow on it. So that potentially is a problem if we do remove it. So we'll leave it in for now. If it becomes a huge issue that we have one pixel too many, then we can always go in and see if we can do something about that particular issue. For now, this should suffice. This, for the most part, should work as long as we don't specify any of the specialty characters. So A to Z, 0 to 9. All the regular symbols like exclamation point, quotation marks, at, hashtag, dollar, percentage, ampersand, slash, backslash, all those regular characters are pretty much in the exact same position on basically any kind of text encoding across every platform. So they are pretty much the same. This should, for the time being, work just fine. Granted, we are aware that we need to, at some point, convert these into proper ASCII encoding so we can correctly reference the correct glyphs to draw. Okay, calculate required width. So we'll place a call to that, and we will then we'll call this surface width equals calculate required width, reference the chat elements that we just got from the chat converter. And this will then tell us exactly how many pixels we need to be able to draw this. In effect, this basically becomes the same thing as measure string in the regular graphics object for font rendering, text rendering. We could potentially do that as a public method, I guess, that would allow us to basically pass in a chat text of some kind, and then have it return an actual size to determine exactly how many pixels are required to draw this particular text. Perhaps we'll do that at some point. For now, we'll just leave it at that as is. Now, actually, why don't we do that right away? Probably not that bad an idea. Yeah, we'll do that. Grab this, move it down here, and rename it. Let's see, we'll put it down here. There we go, and then we will rename this to to become measure string. And then we'll do an overload, so it can accept either an existing list of elements or just a chat string. Yeah, let's do this. Size, and then measure. There we go. And then have this return new size, which would be result, comma. That would then be the line height, like so. And then we need an overloaded copy of this, which accepts the actual text itself. Measure string, string chat text, and then I'll borrow this quick, so I don't have to rewrite it, and then do a size result equals measure string ref chat elements, like so. And then here we'll kill that list again. New chat element. I'm just full of typos today. There we go, and then return that one. There we go. Okay. So this should be somewhat capable of calculating the size required. So for this, we'll need to turn this into a size of some kind. We'll call this, I don't know, surface size. That should be fine. Measure string, and then we'll reference the chat elements since we already split those. And then this will then contain in pixels the exact size that we need to make the resulting bitmap to be able to render these texts. Okay. Now, just like we did before, just like we did before, we kind of need to worry about how fast we can do this, as this will become part of UI updating. We may need to do a little bit of trickery to get our actual UI to update fast enough, so it doesn't feel clunky or sluggish, laggy when somebody's using it. Granted, we could, at some point, if we really wanted to, migrate this over to a faster platform if we really wanted to, but I don't really see any point in doing that since we can get away with getting a fairly fast responsive UI just by doing a little bit of trickery behind the scenes in terms of how we actually draw the surface of our UI for all the custom elements. One of the ways that we are currently doing that kind of trickery is in the main form. We preload the server icon PNGs as bitmaps and then simply just draw those straight onto the form surface. When we start doing this stuff with the custom fonts and such, we will eventually end up having a lot of calls to actually draw stuff. And we may want to at some point see about combining those draw calls into, say, a constructed buffer bitmap, so that when we render the actual surface, let's fire it up quick. This is what I'm talking about. These individual elements at the moment are made up of two calls to draw the background and the border of the selection. There's one call to draw the landscape icon. There's one draw call to render the Vanilla Haven text. One more for Sheridan's Vanilla 1.12.2. One more to render port number for the player counts, maximum players, and the icon. So a lot of calls are being made to actually draw this surface. We could potentially do that a bit faster by reducing the total number of calls that we do, although if we did two calls to show two profiles, we would basically be drawing two bitmaps of basically equal size. On top of that, we could do even further trickery by basically utilizing a pixel byte buffer and then simply updating that buffer and then flipping them over to a bitmap, which we then in a single stroke render to the surface of the form itself to speed it up even further. So those are some of the options that we can step into in terms of increasing performance for the UI. At the moment, it renders just fine. It's fairly responsive, even when we resize it to something bigger. At the moment, we don't really need to do a whole lot more optimization to get it working faster. But it's something that we can step into if and when required. If we end up doing these Minecraft font renderings on the main UI as well, then we could potentially think about possibly migrating all of that rendering stuff onto specific bitmaps and then simply just drawing that profile bitmap onto the form whenever it needs to be updated. Just to let us handle only drawing these elements as needed. It's something that we'll figure out when the time comes. All right. Let's see. Yeah, we should have a surface size. When we did the scan of the glyph bitmap, we grabbed a copy of the raw pixel data from the bitmap and stuffed it into a buffer. And then we ran through the buffer to work out where we have transparent and where we have solid pixels for each glyph, and split them up into our glyph setup, like in this construction. And when we need to draw this stuff, we could potentially just draw it on a bitmap. Again, the get and set pixel methods are fairly slow. So the fast way of doing this is basically to um, do the same thing as when we scanned the glyphs, except in reverse order. So we would start by setting up a image buffer that is big enough to fit the text that we want to render into it. That's where our new measure string method comes in, as it calculates the exact number of pixels needed width and height-wise to fit whatever's in the chat elements. That then tells us, oh, we have the option for we have the dimensions of the bitmap needed. So we can also set up a copy of, set up a buffer that can easily fit the text that we want to render onto it. And then we can basically just copy the solid colors into that buffer, and when we're done, convert that into a bitmap by basically just doing a copy from our buffer into the bitmap's active memory, and thereby get that work done a little easier. And I do apologize, I am a little bit distracted at the moment. It actually seems that I need to, unfortunately, call it a day here. Yeah, I do have to call it a day here. Something came up that I need to take care of, unfortunately. So we'll call it a day here, and then we'll do all this specific rendering next time. We'll look into figuring out how to do proper ASCII conversion so we can render these glyphs correctly. And then see if we can get this text rendering working. For now, though, thank you very much for joining in and for watching, and I'll see you guys next time.